Okay, so welcome to another Level 3 tutorial. This time we're talking about ancillary equipment on the Ford Drinian. First piece of ancillary equipment we're likely to come across is the shake. The shake you tend to find on old paper machines, but not so much on new paper machines. Rather than the breast roll being held on a rigid structure, it's held on a flexible structure, allowing the breast roll end of the wire to be swung backwards and forwards. As you can see here, typically on old machines the stroke is long and slow. On the faster machines the stroke is short and a lot more rapid, and on very modern machines they don't have it at all. The idea of stroke is to create this shake action, and this shake action in turn will reorient the fibres. It will put the fibres more into a machine direction mode, and also fibres that are at an incline that come into the sheet at this sort of angle, it will level out. So it will reduce the caliper of your sheet. You can take a calculation here, the frequency squared multiplied by the amplitude multiplied by the machine speed gives you a factor that we call shake intensity. And shake intensity will relate to improvements in formation. As I mentioned earlier, shake intensity will affect sheet caliper, it will affect fibre orientation, it can be used to improve formation, it will affect retention, it will usually lower retention, and it will also change the position of the wet line because the sheet is being compacted. If it's compacted, water finds it more difficult to get through the sheet, and therefore the wet line will move down towards the couch roll. Another device, of course, is the dandy roll. This is the only roll that we find on top of a paper machine, and the job of the dandy roll is twofold. A plain dandy roll will simply improve the formation of your sheet. It will move the fibres around a little bit, break up any fibre flocks and help you to improve the sheet. The other thing, of course, the major reason for using a dandy roll is it can impart a watermark. An image on the surface of the dandy roll made by usually copper wire that can either be sewn in place or it can be brazed in place will come down, go into the surface of the sheet and just shuffle the fibres away very, very slightly. This will produce areas of the sheet that are less dense, and therefore they will allow more light to travel through. There's a big difference between a dandy roll producing a watermark and a vat machine producing a watermark. On a vat machine you can actually get what's called a full range of tones. So in other words, you can make the paper thicker or you can make the paper thinner and get a full tonal range when creating a picture, and therefore you'll have a wonderful 3D image. With a traditional watermark on a traditional Ford Drinian with a traditional dandy roll, you shuffle the fibres away, and so you can only make thinner areas. There's nothing you can do to make thicker areas, and therefore you only have a half tonal range. One thing that dandy rolls do not do, of course, is aid dewatering. They're there to put a watermark in the sheet, they're there to improve the formation of the sheet, but they do not help to dewater the sheet. And it's important that dandy rolls are kept very clean. If they're not kept clean, then you'll get a problem called dandy picking, where fibres will be picked out of the sheet. This is the construction of a dandy roll. We have a set of hoops that we call annular rings. Linking all those hoops, there are some longitudinal rods. Then we have a coarse cross-section bracing linking all those rods, and then a coarse backing wire, and then finally a fine wire, similar in construction to that of a traditional forming fabric. Dandy rolls are usually made out of, or can be made out of stainless steel, but they're usually made out of phosphor bronze. Another piece of equipment, of course, very important, is edge jets. If we didn't have edge jets, then the sheet edges were very jagged and there'll be a great tendency for them to rip or tear. And so by controlling the edge with an edge jet, you'll get a nice smooth edge, and therefore you're less likely to get any sort of tearing action. And of course you're not processing unwanted paper, so you can also use this to some extent to control the decal of your sheet. Some people even have an edge jet right in the middle of the sheet that's being formed and reel up 2 rolls rather than reeling up 1 roll. Fabric cleaning is very important. In another video we talk about chemical showers and water jets. This is one of the more modern types of cleaning operations, where we have this head which rotates, high pressure showers coming out of there, and sometimes even if they're very low down, a vacuum to also suck it back. So a summary of what we've talked about in this section today. We talked about shake. It will affect major sheet properties such as calibre, orientation, formation, retention and the position of the wet line. The size of the dandy is quite important. The faster the machine goes, the faster the dandy will turn if you have a small dandy, and therefore as the machine speed gets bigger, then the dandy should also get bigger, so that you don't increase the linear velocity, linear velocity too much. So for example, up to about a ½ metre diameter is suitable for machines that run up to 300 metres a minute. Once you're going past 300 metres a minute, up to about 660-ish metres per minute, you need a 1 metre diameter dandy. And once you get beyond 660 metres a minute, going up to about 900, you need a 1.5 metre diameter dandy. And so on. As this gets bigger, bigger dandies. What do we use a dandy for? A dandy is used to impart a watermark to the sheet or to improve formation, but not dewatering or drainage. You should be able to reproduce the construction of that dandy roll. So the annular rings, the rods going across, the bracing, the coarse wire, and then the fine wire mesh. And finally, edge jets. Edge jets are there to control decal. They remove ragged edges, and so they reduce sheet rates. Oh, sorry, not final. Here's the final. Final, modern cleaning doesn't just use static needle jets. They now use rotating high-powered jets. Thank you for listening to this tutorial, and you can find us on all this social media.